In many organizations that I work with, teams test quality in, they don't build it into their product. And that has a very specific impact on engineering excellence within your organization. So when you test quality in, you're effectively allowing engineers to say, well, it's okay, the testers will catch that in the next piece. But the problem with that is the further you get from the engineers writing the code, the more expensive it is to fix, right? With production, finding something in production being the most expensive thing to fix. So even waiting until QA validation, where you've already gone through, you might have, I'm working with a customer at the moment, and they have working in a team environment. They then push that into a preview environment, and that preview environment is where the testers run. But that's is already in main. It's already polluting main by the time the testers are getting a hold of the content. So if we find a problem there, that's another branch, another pull request, another change coming into the system. Now, we do need those testers to find those problems if we've got them, but we would rather those testers didn't find any problems. We would rather find them sooner. And in order to do that, you need automation, you need integration, you need continuous build, you need CI, CD, you need all of those things. So great way to validate your architecture right from the start, that you're making code that is testable, that is just the code that you need, that it does what you expect it to do, is TDD. Test-driven development is not a testing strategy. It's not a replacement for QA. TDD is an architectural and design strategy. But you can also add on to that things like static code analysis, right? And although you don't want to take a existing legacy app and turn on all the static code analysis, because you'll just get a million errors and error overload and nobody will want to do anything with it. But what you can do is turn on specific things and go fix those things through your product. Do a little refactor every now and again to get rid of one thing. Okay, now that's turned on. If people get a warning, it's because they're doing something that we've gone through and fixed in our code base. And then keep doing it a little bit at a time, turning something on in static analysis that you want to make sure that your engineers aren't doing, fixing it throughout your application, and then having that enabled so that developers get those warnings. Also, code review policies. Now, although this is where I favor trunk-based development, right? And long code reviews are the antithesis of trunk-based development. You want to get things into that trunk as quickly as possible. Whatever you call it, maybe main, might be trunk, right? But whatever you call it, you want to get things in there as quickly as possible. So you want to automate as much as possible. I use pull requests as part of the code review policies to apply the policies, and those policies are generally automated. So most of the time, a pull request is automatically approved and automatically merged into the system, and it's only not merged if there are infractions which need to be fixed. And one of those checks that I do have is an AI check. So AI is checking the code that we're writing against the policies that we've written as a team, and flagging things that don't meet those policies, right? So that then we have to respond to those things, and either we ignore them, which sometimes we do because it's a little bit overzealous sometimes, but a lot of the times it catches things. But it means that we don't stop at the pull request unless there's an actual thing that we need to go look at, right, and interrupt. So that gives us that balance between getting things into main as quickly as possible and validating that main is the right thing, that that it's good, that it's high quality. And for your team, you would need to decide what that level is. But even catching things going into main at the pull request level is too late. We want to be catching them at the engineer level. Shift left. Get as many things that you're doing as close to the software engineers and as fast as possible. I love the story of the Azure DevOps team when they were building Azure DevOps, when they first moved from a 2-yearly release cycle to a 3-week release cycle. One of their biggest blockers was that their full regression, their tests, their equivalent of Selenium tests, were taking 24 to 48 hours to tell them whether they've been successful. You can only run so many of them at once. So now you're doing rolling builds and bulking up developers' changes into this rolling test enterprise, which means that it could be 48 hours for a developer to find out that they've got a problem, or it could be more, right? It could be double that. If you just get a change in just after the rolling build finished, it picked up the changes before yours, and now you've got to wait for that 48 hours to finish, and then your changes are picked up in a further 48 hours before you find out that you've got something wrong. So those types of long-running tests are not building quality in; they're testing quality in. Still, that's a lagging, severely lagging indicator from the engineer's perspective. So they had 36,000, something like that. Something like 36,000 of these long-running system tests that they would run. And they worked over a long period of time. It was over 4 years, paying back a little bit at a time to slowly move those tests from long-running system tests to fast-running unit tests with stubbing out, with mocking, with all of the tools that you would expect to use at that level. And some of that is using, if you build products with solid principles, with good engineering practices, then it makes it more testable, easier to do those things with. So they started doing that. And over that 4 years, they took it from 36 hours, 48 hours, sorry, for 36,000 tests to 3.5 minutes for 80,000 unit tests. And that gave them the same level of security. I'm going to put it that way. They designed it that way, gave them the same level of security that they had with the other tests, the same level of confidence that they'd not broken anything, that they were doing the right thing, that they had that in there. So that means that fewer things were caught by that long-running tests, and eventually they could just be removed, and they no longer do that long step of tests because they're confident in their shift left test infrastructure. That's what we all need to do. We all need to move these tests as far left as we can, and then we need to figure out which of these things are taking too long, and figure out for our application and our context, how do we shorten those feedback loops? And that's the fundamental premise of Agile, fundamental premise of Scrum, fundamental premise of DevOps within all of these contexts. And Azure DevOps is a tool designed by a team that went through this journey for teams that go through and have gone through this journey. So it provides capabilities that enable those practices and enables those practices at scale. And the Windows team use this. I think it's 4,500 software engineers, 15,000 people working on a Git repository that's over 350 gig at the tip, right? These are massive projects, all the way down to, I've got a little repo, I'm doing a little build, and everything can be done in a few minutes. I have a project I'm working on at the moment that my time from cutting code to automated build with a pull request is about 1.5 minutes. And then if that's approved, another 1.5 minutes into preview. If that's good, another 1.5 minutes into production, right? That really shortens that feedback loop. You have those repeated cycles, figuring out earlier that we've messed it up. So if you want to build quality into your process rather than testing it in. Let's help you design an engineering workflow that works for you.